Hello class, over the next 5 lessons you are going to complete some flipped instructions which are to take and do your notes at home so we can maximize our time in class. It's important that during these videos you pause to write down notes and complete problems and then get back to the instructions. Draw 3 intersecting lines so that each line crosses each other at a different point. If drawn correctly, you drew a triangle. Even though these lines overlap, we can kind of look at the interior intersection. Today we're going to explore the properties of triangles. Each point where the line intersects is known as a vertex, or vertices would be the plural. Some things you may have written down about this shape are kind of listed below. We're going to explore each of these different areas throughout this unit. What are some relationships among the interior angles of a triangle? So we have angles 1, angle 2, and angle 3, and notice that the marking shows that they are each a different measure. So pause here and write down a few things that you can tell about these relationships. The sum of all these 3 angles is 180 degrees. You see over here, this is our symbol for angles, and we're going to see that a lot in there. And of course, when we talk about angles, we're going to use that degree symbol. So over here we have 180 degrees minus angle 1 minus angle 2 would be the measure of angle 3, and so on. Same is true if I subtract angles 1 and 3 or angles 2 and 3. The side of each statement is always, sometimes, or never true, and draw a picture as your evidence. So again, pause and take a minute to do this. Can a triangle be both obtuse and right? Can a triangle be both acute and right? Can a triangle be both isosceles and acute? Can a triangle be both regular and equilateral? What we would have said here is never, never, sometimes, and always, right? So to be obtuse and right triangle means it has one 90-degree angle, and obtuse means it's greater than 90 degrees. Acute means it is less than 90 degrees, and right angle, again, is 90 degrees. Isosceles means that the triangle has 2 equal angles, right? And those could be sometimes, right? Because we could have a 60-60-60 or 70-70-40. The triangle be regular and equilateral always, since regular and equilateral are the same thing. So it's a little math joke for you at the end. Theorems, postulates, lemma, oh my. In geometry, we were able to make generalizations due to the work done by mathematicians before us. These mathematicians were able to develop hypotheses and come to reasonable conclusions supported by evidence. In this unit, we will use these conclusions to support our findings for various tasks. And recall from our last lesson, we discussed logic and conditional statements, where we're going to use that a lot in our proofs. Now, other things that we explore here are theorems, postulates, and a lemma. And it's not necessarily important that we know these definitions, but the idea is that, again, mathematicians have set these out for us to be true, and we continue to use this mathematical thinking in our processes. Here's a little investigation of interior angles. I want you to draw and cut out a triangle with any dimensions. Tear off the 3 corners of the triangles and place them next to each other as shown in the diagram. So make sure that you label those corners 1, 2, and 3 before you tear them off. Make a conjecture about the sum of the measures of the interior angles and support it with specific evidence from this activity. So you see, as you go from this first diagram here to the second diagram, you should be able to line these up on a straight line. What would that tell you? If you said that measure of angles 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees, you're on the right track. This is known as the interior angle theorem. All right, it states that the sum of all interior angles of a triangle will always total 180 degrees. Let's look at another investigation. Again, cut out a triangle of any side length and label these corners A, B, and C this time. So you want to place the triangle on a piece of paper and extend one side out here of this angle, right? So we're going to kind of measure out here. We'll call this angle BCA. Whenever an angle has multiple possible angles that can be formed, you want to use 3 letters. So here I can call this angle A and I can call this angle B, but here I can't call that angle C because we could have BCA or BCD, and that's our exterior angle. So tear off two of the corners that are not next to the exterior angle. So again, you'd tear off A and B and put them over here along the straight line. Make a conjecture about the relationships between the measure of the exterior angle of the triangle and the measure of the non-adjacent. What you see here is the measure of angle A plus measure of angle B equals to the measure of angle BCD. This is known as the exterior angle theorem. It states that the measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent, which means the ones that are not touching, interior angles of the triangle. There are two ways for us to classify triangles. What that means is to state what type of triangle they are. The first way is to classify triangles by their sides or side lengths. The term congruent means that an object is the same size and shape. The only difference between these objects may be its positioning, i.e. a transformation, which is a reflection or a rotation, or a translation, which means moving an object up or down or left or right. If you look at this first triangle, it has no congruent sides, and it's kind of shown here by these markings. Here, each different marking shows it's a different measurement. This triangle here has two congruent sides, and this triangle here has all three sides are congruent. Could you classify the triangle? Write them down now and see if you're correct. If you wrote the first triangle is scalene, that means that three side lengths are different. The second triangle would be classified as isosceles, and the third triangle would be classified as equilateral or regular. Now, equilateral is not the same as equiangular. We'll talk about that later, but the idea of equilateral, lateral means side, so it has to have three of the same sides. When we classify triangles by their angles, that's a little bit different. If I look here, this blue triangle has three acute angles, the yellow triangle has one right angle, the pink triangle has three congruent angles, which means same size and shape, and our purple triangle has one of two angles. So take a moment to write down what you think. How would you classify these triangles? Our first triangle here, blue, is an acute triangle, which means each of the three angles is less than 90 degrees. Here, shown by this little square, shows we have a right triangle, which means this is 90 degrees, and it also tells us that there may be a relationship between these two angles we'll explore later. Three congruent angles, which would tell us that each of these angles is equal. So if I take 180 divided by 3, I get 60, 60, 60 for each of these angles. So it's equiangular. You see that was different than equilateral, which talked about the side lengths. And then our last one is an obtuse angle, which means that one of these angles measures more than 90 degrees. And you can kind of get a visual idea, but we don't want to make any assumptions about that. Drawing conclusions. So given the measure of the two interior angles of a triangle, how can you find the measure of the third angle? Draw a triangle that has one right angle. How can you show that the two acute angles of a right triangle are complementary? Complementary means it adds up to 90 degrees. A good way to remember between complementary and supplementary is complementary starts with C, C before S, 90 before 180. Okay, so write these down and then come back to the video. Okay, so in our first example there, you might have said that 180 degrees minus measure of angle 1 minus measure of angle 2 equals a measure of angle 3. And that was something we explored early on in this lesson. Our second one, we're going to write this as a conditional statement. If 180 degrees minus 90 degrees equals 90 degrees, then the measure of angle 1 plus the measure of angle 2 equals to 90 degrees. And we're going to discuss that briefly in the slide prior, talking about in a right triangle. If you know it's a right triangle, then the other two remaining angles are 90 degrees. Let's apply this to some algebraic examples. We want to find the value of x and the measure of each unknown angle. In our first example here, we see that these three angles here should total up to 180 degrees. And in our second example here, we see that these two angles, since we have a right angle, should total to 90 degrees. So we can kind of shortcut that, or we could say these three angles together equal to 180 degrees. So solve for x for each, and then plug back in, and then come back to the video. again, our hint here is that the sum of all interior angles was 180 degrees. Our first example, we set up our equation, 3x plus x plus 60 equals 180. We solve by combining like terms, use inverse operations, and we get x equals 30. Now again, it doesn't mean that it's 30 degrees because we're substituting in for x. Once we plug in, we can say, therefore, it is a 30 degree, 60 degree, and then 3 times 30 would make 90 degrees. So we classify this as a right triangle. Looking at our second example here, I've used the 180 degrees rather than setting this up as 90 degrees. So 2x plus quantity x minus 6. And the reason we want to put this in a grouping symbol, it's really important, is that if this were a negative sign, it would distribute and make these opposite. So you always want to put a grouping symbol in for these. Plus 90, we combine like terms, use our inverse operations, and we see that x equals 32. And again, it's not 32 degrees, it's our value for x. Therefore, that's our little 3 dots right there. It is a 26 degrees because 32 minus 6 is 26. 2 times 32 is 64. 90. So again, we have a 90 right triangle, 90-degree right triangle. Okay. Our last example here is to use the exterior angles theorem to solve. As a reminder, the exterior angles theorem tells us that angle J plus L should be equal to angle JKM. And here, these two interior angles that are non-adjacent, means not next to the exterior angle, are equal to each other. So we see that here. So set up your equations and solve, and then come back to the video. Our first example, x plus 70 equals 2x minus 5. So I set up this equation where I have my interior angles on the left-hand side and my exterior angles on the right-hand side. That doesn't matter how you set it up, but as long as you set them equal to each other. We're going to be lazy mathematicians, do 2 steps at once, and get our like terms arranged. We see x equals 75. So here, even though x equals 75, it is also the measure of that angle 75 degrees. And here we're going to substitute in x and see that 2 times 75 subtract 5 is 145. So that, therefore, angle JKM is a 145 degree angle. Our last example here, we set up the same type of equation, again being sure to put in this binomial into a grouping symbol in case we had a negative. We don't, but we want to get in that habit. We simplify by combining like terms on the left-hand side, then we use our inverse operations, and we get x equals to 36. So now we substitute in to each of our examples here. 3 times 36 plus 6 is 114 degrees. And then we could also substitute in the 2 times 36 plus 18 to find the measure of this other angle. Okay, that's all for now. I'll see you in the next video.